Welcome to Concept Bites. In just a few minutes, we are going to make machine learning feel like second nature with real life analogies you'll never forget. Let's unlock the secrets of AI together. Imagine your brain as a super smart shopping assistant accompanying you to the shops. It's constantly learning from your choices, even the ones you didn't consciously make. It remembers what you liked before, from your favorite brand of crisps to the quirky mug you bought last month, and subtly suggests similar items next time. It learns from feedback. If you ignore a suggestion or grimace at a particular style, it notes, no, I didn't like that. If you light up at a new arrival, it understands, more of this please. Machine learning works similarly. It's all about learning patterns from vast amounts of past data to help make better and more informed decisions in the future. Have you ever thought how Netflix recommendations works? How does it know what you like? You settle down, open Netflix, and boom, a perfectly tailored list of shows and films appears. Is it a magic? Not quite, but it's certainly clever. It observes all your watching habits. Netflix meticulously tracks what you have watched, how long you have watched it, and even what time of day you prefer certain genres. It then compares your viewing habits with millions of other users, identifying those with similar taste. By finding hidden patterns and connections within the massive dataset, Netflix predicts what you might want to watch next. It's like having a friend who knows your exact movie taste and always suggests the perfect film. This constant learning and adaptation keep you hooked, ensuring you always find something you'll enjoy. Can you think of a linear regression predicting with a straight line? Imagine a keen gardener who wants to know exactly how much fertilizer will make their plants grow tallest. The gardener measures the amount of fertilizer used and the corresponding plant growth. When plotted on a graph, these points might look a bit scattered, but they show a general trend. Linear regression is like drawing the best possible straight line through those points. This line acts as a simple prediction tool. By using this line, the gardener can then predict the future growth of a plant based on a specific amount of fertilizer, even amounts they haven't tested yet. In machine learning, this technique is used to predict continuous outcomes like, say, price, temperature, or growth from existing data. Now, let's take decision trees. Say, for example, we are going to play 20 questions with data. Think of a classic game like that. You're trying to guess an object, and with each yes or no question, you narrow down the possibilities until you arrive at the answer. So first of all, you start your decision and define the main goal. Next, you assess the options and look for any viable solutions available. And then you are reevaluating the risk and finally choosing the outcome to select the best path forward. How about a random forest? This talks about the power of many opinions. Imagine you're trying to make a really important decision, like whether to launch a new product. Instead of relying on one person's opinion, you assemble a diverse committee of experts. Each expert gives their individual opinion based on their own experience and a slightly different perspective of the data. A random forest algorithm builds many individual decision trees, like say our experts, each trained on a slightly different random sample of the data. Just like you combine the oaths or insights from your committee to make a more robust decision, the random forest algorithm combines the predictions from all its individual trees. This collective wisdom leads to more accurate and reliable predictions than any single tree could achieve on its own, making it a highly powerful ML technique. Now coming to support vector meshes. Let's say we draw a perfect boundary. Let's say you're at the beach and you have collected two different types of seashells, smooth, white ones, and rough, colorful ones of course. You want to separate them into two distinct groups. So you draw a line. You could draw a simple line in the stand, but a support vector machine aims to draw the perfect boundary. How about the widest margin? It will find the widest possible margin between the two groups, creating the clearest and most effective separation. And also we can look into the maximum confidence, which will be helping to classify new data points with maximum confidence, ensuring they fall neatly into one group or the other. It's all about finding the optimal dividing line to accurately classify the data. Now let's try to identify the overfitting and underfitting in the outcome. Imagine you're making olive oil. The goal is to get as much rich, flavorful oil as possible from the olives without squeezing too hard and getting bitter pulp. What does underfitting look like here? Too little squeeze? If you don't squeeze the olives enough, you leave most of the oil behind. Your model misses useful patterns and relationships in the data. So the just right thing to do is the optimal squeeze. A perfect squeeze yields the most oil without bitterness. Your model generalizes well, capturing true patterns in the data without being distracted by noise. What will you call an overfitting in this case? Too much of squeezing it. Squeezing too hard extracts not just oil, but also bitter bits of pulp. Your model picks up on random noise and anomalies, performing poorly on new unseen data. Now let's talk about some real-life impacts. Machine learning isn't just for tech giants. It's transforming industries worldwide. Let's take an example of sorting cucumber in Japan. A cucumber farmer used machine learning to automate the sorting of cucumbers by size, shape, and color. Traditionally, a labor-intensive task, the ML system accurately classifies thousands of cucumbers per hour, significantly boosting efficiency and reducing waste. It learns from example, just like a human sorter would, but faster and more consistent. How about a bank fraud detection? Banks globally use machine learning to detect fraudulent transactions in real time. By analyzing millions of transactions, ML algorithms spot unusual patterns like a small purchase followed by a large out-of-character transaction in a different country that indicate potential fraud. These systems learn from past fraud cases, constantly adapting to new tactics used by criminals. Machine learning is like learning something new in life. So with all the above, what we have understood finally? At its core, machine learning is about recognizing patterns, learning from experience, and continuously improving decisions. The real-life analogies we have explored demonstrate that ML is not some abstract magic, but rather a smart, data-driven approach to learning, much like how humans adapt and grow. It recognizes the patterns, learns from experience, and makes improved decisions. So, said that, what new skills could you teach your shopping assistant next? Explore machine learning with curiosity. Your next great idea could be just a pattern away. Thanks for tuning in to understand machine learning concepts. Please comment, share, and subscribe for more quick concept bites. Catch you in the next bite. Stay curious. Bye-bye.